Hello everyone, I am Sakshi from MSc Chemistry first year. Today I am going to read Physical Chemistry Unit 3 Chemical Dynamics branch of chemistry which deal with rate of reaction, factor affecting rate of reaction and mechanism of chemical reaction is known as chemical dynamics. Rate of reaction, it is defined as the change in concentration of any of the product or reactant per unit time. SI unit is mole, liter inverse, minute inverse or moles, L inverse, second inverse, rate law for consecutive and parallel reaction of first order reaction. Consecutive first order reaction, it is a series of sequential reaction where the product of one first order step become the reactant for the next forming intermediate before reaching the final product. A K1B K2C. K1 is equals to rate constant for first step. K2 is equals to rate constant for second step. Both steps are first order with rate constant K1 and K2. However, Kf and Kb have comparable value. A rate law depend upon both the constant can be written. Suppose initial concentration of reactant A is equals to C naught concentration of A, B and C after time T are C A, C B and C C respectively. So we can say C naught is equals to C A plus C B plus C C. Now the rate can be reduced in term of C A, C B and C C. Rate law in term of C A, rate of disappearance reactant of A minus D CA by dt is equals to K1 CA minus dCA by dC by CA is equals to K1 dt. On integrating both sides, minus L and CA is equals to K1 T plus I, where I is equals to integration constant when T is equals to 0. CA is equals to C naught. Equation 1 become L and minus L and C naught is equals to I. Put the value of I in equation 1. Minus L and CA is equals to K1D K1T minus L and C naught. L and C naught minus L and CA is equals to K1T minus L and CA by C naught is equals to K1T is equals to L and CA by C naught is equals to minus K1T. CA by C naught is equals to E epsilon e raised to power minus K1 into T. CA is equals to C naught epsilon power minus K1T. Rate law in term of Cb, rate of formation of intermediate B is dCb by dt is equals to minus K2Cb plus K1Ca. dCb by dt is equals to K1Ca minus K2Cb. Put the value of C from equation 11 in above equation. We can differentiate equation of first order dCb by dt is equals to K1 C naught epsilon raised to power minus K1T minus K2Cb. On integrating both sides, Cb is equals to C naught into K1 by K2 minus K1 into e raised to power minus K1T minus e raised to power minus K2T. Rate law in term of Cc, the overall rate of formation of product C. D Cc by dt is equals to K2 Cb. Put the value of Ca and Cb in equation 4. Cc is equals to C naught minus C naught e raised to power minus K1T minus C naught into K1 by K2 minus K1 into e raised to power minus K1T minus e raised to power minus K2T is equals to C naught into 1 minus e raised to power minus K1T minus K1 by K2 minus K1 into e raised to power minus K1T minus e raised to power minus K2T. C naught into 1 minus e raised to power minus K1T minus K1 e raised to power minus K1T by K2 minus K1 plus K1 e raised to power minus K2 into T by K2 minus K1. C naught into 1 minus e raised to power minus 1 K1T plus K1 into e raised to power minus K1T by K2 minus K1 minus K1 e raised to power minus K2 into T by K2 minus K1. C naught into 1 minus K2 minus K1 into e raised to power minus K1 into T plus K1 e raised to power minus K1 into T by K2 minus K1 into e raised to power minus K2 by K2 into T. C naught into 1 minus into k2 e raised to power minus k1t minus k1 e raised to power minus k1t plus k1 e raised to power minus k1t by k2 minus k1 e raised to power minus k2 into t. C note into 1 minus k2 e raised to power minus k1 into t minus k1 e raised to power minus k2 into t by k2 minus k1. Cc is equals to C note into 1 minus 1 by k2 minus k1 into k2 e raised to power minus k1 into t minus k1 e raised to power minus k2 into t. The equation second, third and fourth can be used to plot the time dependent variation of CA, CB and CC respectively. Here is the graph. Maxima in the concentration of B in addition to time dependent concentration variation of different species. One more important parameter to measure is the maximum B concentration. For this, value of dCB by dt is equals to 0. The differentiation of equation 3 then putting equal to 0. dCB dt is equals to C naught into k1 by k2 minus k1 into minus k1 e raised to power minus k1t plus k2 e raised to power minus k2 into 0 is equals to into t is equals to 0 is equals to minus k1 e raised to power minus k1t plus k2 is equal k2 e raised to power minus k2 into t is equals to 0. K1 e raised to power minus k1 into t is equals to k2 e raised to power minus k2 into t. K1 by k2 is equals to e raised to power minus k2 into t by e raised to power minus k1 into t. K1 by k2 is equals to e raised to power k1 minus k2 into 2. Taking logarithm on both sides, ln k1 by k2 is equals to ln e raised to power k1 minus k2 into t. Ln k1 by k2 is equals to k1 minus k2 into t. T maximum is equals to 1 by k1 minus k2 ln k1 by k2. Put the value of t in equation 3. Cb is equals to C naught into k1 by k2 minus k1 into exponential into minus k1 ln into k1 by k2 by k1 minus k2 minus exponential minus k2 ln k1 by k2 by k1 minus k2. Simplifying and rearranging above equation, CB maximum is equals to C naught by C naught into k2 by k1 e raised to power k2 by k1 minus k2. Rate law in special cases when k2 is greater than k1, value of k1 can be neglected. Equation 5 will become C is equals to C naught into 1 minus e raised to power minus k2 into t. When k1 is greater than k2, value of k2 can be neglected. Equation 5 will become C is equals to C naught 1 minus e raised to power minus k2 t. Parallel first order reaction. The parallel or side reaction may be defined as the reaction in which initial species react to give multiple products simultaneously, where when A1 with K1 then give B and A1 with K2 gives C. K1 and K2 are rate constant. A is initial concentration of A. X is equals to decrease in concentration of reactant after T time. Rate of first R1 and second R reaction are to give as R1 is equals to dB by dt is equals to K1 into A is equals to K1 into A minus X. R2 is equals to dC by dt is equals to K2 into A is equals to K2 A minus X. Oral reaction rate by adding 1 and 2. dx by dt is equals to dB by dt plus dC by dt is equals to K1 AX plus A minus X plus K2 A minus X. dx by dt is equals to K1 plus K2 into A minus X. dx by A minus X is equals to K1 plus K2 into dt. On integration and rearranging above equation, K1 plus K2 is equals to 1 by T ln A by A minus X. On dividing equation 1 by 2, R1 by R2 is equals to K1 A minus X by K2 A minus X, which implies that R1 by R2 is equals to K1 by K2. Hence, the value of rate constant involved, that is K1 and K2, can easily be obtained from use of equation 3rd and 4th. Ionic reaction, single and double pair model. In single pair model, It is considered that two ions which can be same or opposite charge to form a single pair activated complex in this solvent is considered as a continuum with A as the dielectric constant. In initial state, ions are considered as a discrete, while in final state they assume to form a single pair activated complex with R as overall radius. Suppose that we need to charge a conducting sphere of radius r from an initial value of 0 to find final value ze. This can be visualized as a process in which a very small charge as that is a delta is equals to 0 minus z is carried from infinite to this sphere. Za and zb are charge number of participating ions. X is equals to distance of separation between sphere and increment at any time. 4 of electrostatic interaction df between them given as df is equals to del E square d del by 4 pi epsilon naught Ex square. E naught and E are primitives of vacuum and dielectric constant of solvent used. E is equals to elementary charge, that is 1.6 into 10 to the raised power 19. Amount of work done in moving increment chosen by extent dx will be dw is equals to df into dx. Dw is equals to del E square d del by 4 pi epsilon naught Ex square into dx. Double integration with the respectively x is equals to infinite minus r delta is equals to 0 minus z. W is equals to E square by 4 pi epsilon naught E integration 0 to z integration w to infinite to r del by x square d del dx. W is equals to z square E square by 8 pi epsilon naught E r. Work given the above equation is actually the contribution of electrostatic interaction to gives free of ion. GEI is equals to z square E square 8 pi epsilon naught ER. The electrostatic contribution to give free energy of discrete ions and activated complex written GEI A is equals to ZA square E square by 8 pi epsilon naught ERA. GEI B is equals to Z square B E square by 8 pi epsilon naught ERB. G star EI is equals to ZB plus ZB square E square by 8 pi epsilon naught E R star. Change in electrostatic contribution can be obtained by subtracting the sum of individual contribution from overall contribution. Del G star EI is equals to ZB plus ZB square E square by 8 pi epsilon naught E R star minus Z square A E square by 8 pi epsilon naught E R A minus Z square B E square by 8 pi epsilon naught E R B. Del G star EI is equals to E square by 8 pi epsilon naught E into ZB plus ZB square by R star minus Z square A by RA minus Z square B by RB. Correcting above equation from non-electrostatic contribution del star NEI, the total molar free energy change for whole process given as del G star is equals to del G star NEI plus del G star EI is equals to del G star NEI plus N E square by 8 pi epsilon naught E into ZB plus ZB square by R star minus Z square A by RA minus Z square B by RB. From activated complex theory we know K is equals to RT by NH E raised to power minus del G star RT. Put the value of del G star in above equation. K is equals to RT by NH e raised to power minus del G NEI by RT plus NE square by RT 8 pi epsilon naught E into ZB plus ZB square by R star minus Z square A by RA minus Z square B by RB. Taking log on both sides, ln K is equals to ln RT by NH minus del G star NEI by RT minus NE square by RT 8 pi epsilon naught E into ZB plus ZB square by R star minus Z square RA minus Z square B by RB can be expressed as ln K is equals to ln K naught minus NE square by RT pi 8 pi epsilon naught E into ZB plus ZB square by R star minus Z square A by RA minus Z square B by RB. K naught is equals to magnitude of rate constant. Double sphere model. According to this model, two ions which can same as opposite charge combine together to form an activated complex. In initial state, the ions are considered as a discrete, while in final state they assume to form a dumbbell like coordination with R as the distance of separation between their center. Solvent is considered as continuous surrounding with A and as dielectric constant. If Za and Zb are the charge number of participating ions and X as the distance of separation, the force of electrostatic interaction FAB between them can be given from Coulomb's law as FAB is equals to ZB square by 4 pi epsilon naught Ex square E and E epsilon naught and are epsilon primitive vacuum and dielectric constant of solvent used. E is equals to elementary charge. Value of a parameter varies from epsilon infinity to r with mutual approach of two ions. Amount of work done in volume to ions closer by an extent dx. Work is equals to force into displacement. dw is equals to fa ab into dx. dw is equals to minus za zb square by 4 pi epsilon naught epsilon x square dx minus sign indicate of decreasing separation. Total amount of work done in moving two ions from x is equals to infinity to x is equals to r will w is equals to minus integration x from r za zb square by 4 pi epsilon naught epsilon x square dx. W is equals to za zb square by 4 pi epsilon naught epsilon r multiplying by Avogadro number and would give value of corresponding molar free energy del g star ei epsilon naught. Del G EI is equals to Z N Z A Z B square by 4 pi epsilon naught epsilon r. Correcting above equation from non-electrostatic contribution del G star NEI is the total number free and energy change for whole process given as del G star is equals to del G star NEI plus del G star EI is equals to del G star NEI plus NZA ZB square by 4 pi epsilon naught epsilon r. From activated complex theory, K is equals to RT by NH e raised to power del G star by RT. Put the value of del G star from equation 1 to 2. K is equals to RT by NH e raised to power minus del G star NEI by RT plus NZA ZB square by RT 4 pi epsilon naught epsilon r. K is equals to RT by NH e raised to power minus del G star NEI by RT into e raised to power minus NZA ZB square RT 4 pi epsilon naught epsilon r. Taking log both sides, ln K is equals to ln RT by NH plus ln e raised to power del G star NEI by RT plus ln e raised to power NZA ZB e raised to power 2 by RT 4 pi epsilon naught epsilon r. Ln K is equals to ln RT by NH minus del G star NEI by RT minus NZA ZB square by RT 4 pi epsilon naught epsilon r. It can be expressed as ln K is equals to ln K naught minus NZA ZB square by RT 4 pi epsilon naught epsilon r. K naught is equals to magnitude of rate constant. Influence of solvent and ionic strength. The rate of reaction. In the case of ionic strength, reaction is strongly dependent upon the nature of solvent used and ionic strength. Influence of the solvent. In order to study it on rate of ionic reaction, rate equation derived using double sphere model, that is ln K is equals to ln K naught minus NZA ZB square by 4 by RT 4 pi epsilon naught epsilon r. N and R represent Avogadro number and gas constant. Rearranging equation, ln K is equals to minus ZA ZB square into 1 pi 4 by RT 4 pi epsilon naught R epsilon plus ln K naught. It is obvious from the plot that equation to hold very good over a wide range of dielectric constant. La derivation observed at lower value of E. If M is experimental slope, the from equation to M is equals to minus NZA ZB square by RT 4 pi epsilon naught R. From principle of thermodynamics, del G by del T P is equals to minus electrostatic contribution to gives free energy using double sphere model. Del G star EI is equals to NZA ZB square by 4 pi epsilon naught epsilon R. Only quantity which is temperature independent is above equation is epsilon on differentiation above equation with respect to temperature at constant pressure. Del S star EI is equals to minus del into del star EI by del T. P is equals to minus ZAZB square by 4 pi epsilon naught R del 1 by E by del T into P. Del S star EI is equals to NZAZB E square by 4 pi epsilon naught E square R del E by del T P. Del S star EI is equals to NZAZB E square by 4 pi epsilon naught ER del ln E by del T P. Knowing the dielectric constant of solvent and R, the entropy of activation can be obtained. The entropy of activation is negative and decrease with an increase in ZAZB. Influence of ionic strength. I is equals to 1 by 2. I is equals to 1. I is equals to n MiZi square. Mi and Zi are molarity and change number of IH species. On increasing ionic strength, increase the rate of reaction if charges on reacting species are of same sign. The reaction rate has been found to follow a declining trend with increasing ionic strength of a reaction in ions are opposite sign. Here ZA plus B raised to power ZB is equals to X raised to power ZA plus ZB gives P. Broad's proposed rate equation relation reaction rate and activity coefficient R is equals to K naught AB YA by YX YA by YX kinetic activity factor. Rearranging above equation R by AB is equals to K naught YA by YX. Left hand side simply equals to second order reaction. K is equals to K naught YA by YX. Taking log on both sides, log K is equals to K naught plus log YA by YX. Log K is equals to log K naught plus log YN plus log YB minus log YX. Calculation of mean ionic activity coefficient with ionic strength given by Debye-Huckel theory. Log Yi is equals to minus Bzi square under root plus minus B is equals to Debye-Huckel constant. Using concept of equation 2 and I, we get log K is equals to log K naught plus minus Bz square A under root I minus Bz square B under root I plus Bz square X under root I. Log K is equals to log K naught minus Bz square A under root I minus Bz square B under root I plus Bza plus Zb square under root I. Log K is equals to log K naught plus B into Za plus Zb square minus Z square A minus Z square B under root I. Log K is equals to log K naught plus Bz square A plus Z square B plus 2ZAZB minus Z square A minus Z square B under root I. Log K is equals to log K naught plus 2BZAZB under root I. Arranging above equation, log K is equals to 2BZAZB under root I plus log K naught. The equation of straight line with positive slope and positive intercept. Log K naught Y is equals to mx plus c. For aqueous solution at 25 degree Celsius, 2b is equals to 1.02. Equation third become log K is minus log K naught is equals to 1.022 Za 1.02 Za Zb under root I. Log K by K naught is equals to 1.02 Za Zb under root I. Chain factor hydrogen bromine reaction and hydrogen chlorine reaction. Orthopara hydrogen conversion. Chain length. Apparent activation energy of chain reaction. According to Max Bornstein proposed the idea of chemical chain reaction that if two molecules react with each other, some unstable molecule may also be formed along product that ions further react with reactant molecule with a much higher probability than initial reactant. Hydrogen bromine reaction. It is a typical case of stationary type chain reaction and is equals to 1 for which overall reaction can be written as below. S2 plus Br2 is equals to 2HBr. Elementary steps as a initiation. Br2 K1 B2 Br. Propagation. Br plus S2 K2 HBr plus H plus Br2 K3 HBr plus Br. Inhibition. H plus HBr K4 H plus Br. Termination. Br plus Br K5 Br2. Net rate formation of HBr must be equal to the same Sum of rate of formation and rate of disappearance of the same. dHbr by dt is equals to K2 Brs2 plus K3 Hbr2 minus K4 HBr. To obtain oral rate expression, apply steady state approximation on x and on h and br first. dH by dt is equals to 0 is equals to K2 Br S2 minus K3 HBr2 minus K4 HBr. Similarly, d Br by dt is equals to 0 is equals to 2 K1 Br2 minus K2 BH into S2 plus K3 H into Br2 plus K4 H into HBr minus 2 K5Br square. Taking negative both side of equation 1 minus K2Br into S2 plus K3R H Br2 plus K4 H into HBr is equals to 0. Put above result in equation second. 2k1 br2 plus 0 minus 2k5 br square is equals to 0. 2k5 br square is equals to 2k1 br2 br is equals to k1 by k5 raised to power 1 by 2 br2 raised to power 1 by 2. Rearranging equation second again, k3h into br2 plus k4h into hbr is equals to k2 br into s2 h is equals to k2 br into h2 by k3 br2 plus k4 hbr. Use value of Br from equation third in above equation. Take from H is equals to K2 into K1 by K5 power 1 by 2 Br raised to power 1 by 2 S2 by K3 Br2 plus K4 HBr. Rearranging equation 1 in different mode. K2 Br into S2 minus K4 H into HBr is equals to K3 H into Br2. Use above result in equation. We have d in hbr by dt is equals to k3h into br2 plus k3h into br2. dhbr by dt is equals to 2k3h into br2. After putting value of h from equation 4 and 5, take the form dhbr by dt is equals to 2k3k2 into k1 by k5 raised to power 1 by 2 br2 raised to power 3 by 2 s2 by k3 br2 plus k4 hbr. Taking k3 br2 as common in denominator, dhbr by dt is equals to k2 into k1 by k5 raised to power 1 by 2 br2 raised to power 1 by 2 s2 by 1 plus k4 by k3 hbr into br2. Two new constant as k dash is equals to 2k2 by into k1 by k5 raised to power 1 by 2 and k double dash is equals to k4 by k3. Use above result in equation 6. dhbr by dt is equals to k dash br2 raised to power 1 by 2 h2 1 plus by 1 plus k double dash hbr by br2. Initial reaction rate expression can be obtained by neglecting hbr, that is 1 plus k double dash hbr by br2, which is similarly equal to 1 dhbr by dt not is equals to k dash br2 raised to power 1 by 2 h2 not. Hence the order of hbr reaction is in initial stage will be 1.5 only, that is first order with respect to hydrogen and half with respect to bromine. Ortho para hydrogen conversion. Ortho hydrogen can be converted into para and can easily be measured in temperature range of 700 to 800 degrees Celsius. Conversion is homogeneous in nature and order of conversion is 1.5 as total. PS2 equilibrium with 2HS plus PS2 K2H plus OH2 equilibrium constant written as K is equals to S square by P minus S2 H square is equals to K P minus S2 H is equals to K raised to power 1 by 2 P minus H raised to power 1 by 2. Net rate of conversion of PS2 must be equal to sum of rate of formation and rate of disappearance of sum, that is d PS2 d by dt k to PS2 into h. Put the value of h in above equation. D into d PS2 dt k to PS2 k raised to power 1 minus 1 by 2 PS2 raised to power 1 by 2 d PS2 by dt is equals to k2 k1 by 2 PH2 raised to power 3 by 2. Oral activation energy of conversion is equals to E2 plus D2 is equals to activation energy of second step. This is equals to dissociation energy. Change length Chain length. It is defined as the average number of times that the closed cycle of chain propagation step is repeated. In other words, chain length of any chain reaction is equal to the reaction of rate of or reaction to rate of initiation step in which active particles are generated. Kinetic chain length is equals to Rp by Ri. Rp and Ri rate propagation and initiation. Apparent activation energy of chain reaction. In order to understand energy profile of chain reaction, consider a typical chain reaction of synthesis of hydrogen bromide from its element S2 plus Br2 plus 2HBr. Elementary step initiation is equals to Br2 plus M is K1 Br2 propagation Br plus H2 K2 HBr plus H plus Br2 K3 HBr plus Br inhibition H plus Br K4 H2 plus Br termination 2 Br plus M K5 M star Br2. Overall rate low for such chain reaction are quite complex and have no integrational order. Net rate of formation of HBr as dHBr at by dt is equals to 2k2 into k1 by k5 raised to power 1 by 2 br2 raised to power 1 by 2 s2 by k1 plus k4 by k3 hbr by br2. New constant as k dash s is equals to 2k2 into 1 by k1 by k5 raised to power 1 by 2 and k double dash k4 by k3. Use the constant in equation 1. D into HBr by dt is equals to K dash Br2 raised to power 1 by 2 HB H2 by K1 plus K double dash HBr by Br2 in initial rate expression obtained by neglecting HBr, that is 1 plus K double dash HBr by Br2 is equals to 1. D HBr by dt naught is equals to K dash Br2 or 1 by 2 H2 naught. The order of HBr reaction in initial stage will be 1.5 only on expanding equation. Second, DHBr dt naught is equals to 2k2 k1 by k5 raised to power 1 by 2 br2 raised to power 1 by 2 h2 naught. Overall rate constant written as k overall is equals to 2k2 k1 by k5 raised to power 1 by 2. Assume E1, E2 and E5 are activation energy for first, second and fifth step. Individual rate constant K1 is equals to A raised to power minus E1 by RT. K2 is equals to E raised to power E raised to power minus E2 by RT. K5 is equals to A E raised to power minus E5 by RT. Put all of values in equation third. K overall dash is equals to 2 e raised to power minus e2 by rt a e raised to power minus e1 by rt by a e raised to power minus e5 by rt raised to power 1 by 2 is equals to a e raised to power minus e2 by rt into e raised to power minus e1 plus e5 by rt 1 by 2. K overall is equals to a e raised to power e2 by rt e raised to power minus e1 plus e5 by 2rt is equals to 2a raised to power minus 2e2 minus e1 plus e5 by 2rt is equals to 2ae raised to power minus 1 by 2 into 2e2 plus e1 minus e5 by rt. Comparing our result with Arrhenius rate constant k is equals to a e raised to power minus ea by rt, we get ea is equals to 1 by 2 into 2e2 plus e1 minus e5 is equals to e2 minus 1 by 2 into e1 minus e5 in above general form. Ea is equals to ep minus 1 by n into ei minus et. N is equals to order of termination step with respect to chain carrier. Photochemical reaction hydrogen bromide and hydrogen chlorine reaction. There are many chemical reactions which occur also when the reactant are exposed to light called as photochemical reaction. First law of photochemistry it states that when light is allowed to strike the reaction mixture, it can be partially transmitted, reflected and absorbed portion of incident light which is responsible to carry out any chemical reaction. Second law of photochemistry it said that one photon of light must be absorbed from one molecule to get activated in Photochemical reaction by chemical system. Photochemical reaction between hydrogen and bromine. From hydrogen bromine reaction, we have a result DHBr by dt is equals to 2K2 into K1 by K5 raised to power 1 by 2 Br2 raised to power 1 by 2 H2 by 1 plus K by K4 by K3 into HBr by Br2. Now, since 2K1 into Br2 is equals to 2IAB, then K1 raised to power 1 by 2 Br2 raised to power 1 by 2 is equals to IAB raised to power 1 by 2. Use this result in equation 1. DHBr by dt is equals to 2K 2 IAB by K5 raised to power 1 by 2 S2 by 1 plus K4 by K3 into HBr by Br2. Hence, the rate of hydrogen bromine reaction is directly proportional to square root of the intensity of absorbed radiation. Photo chemical reaction between hydrogen and chlorine. Overall reaction S2 plus Cl2 HV2 HCl. Elementary step initiation Cl2 plus HVK1 2Cl propagation Cl plus H2K 2 HCl plus H HCl K3 HCl plus Cl. Termination 2Cl at the walls K4Cl to net rate of formation of HCl DHCl by dt is equals to K2ClH2 plus K3HCl to obtain overall rates we need to apply steady state approximation on H and Cl first. dH by dt is equals to K2 ClS2 minus K3 HCl2 is equals to 0. Similarly, dCl by dt is equals to 2K1 Cl2 minus K2 ClS2 plus K3 HCl2 minus 2K4 Cl is equals to 0. Take negative both side minus K2 Cl H2 plus K3 HCl2 is equals to 0. Use the box equation in equation 1. 2K1 Cl2 plus 0 minus 2K4 Cl is equals to 0. 2K1 Cl2 is equals to 2K4 Cl. Cl is equals to K1 by K4 into Cl2. Rearranging above equation, K2 ClH2 minus K3 HCl2 is equals to 0. H is equals to K2 Cl2 ClH2 K3 C by Cl2. Using value of Cl from equation second in equation third, H is equals to K2H2 into K1 by K3 into Cl2 K4 into Cl2 is equals to K1 K2H2 by K3 K4. Using value of Cl and H, DHCl by dt is equals to K2 in K1 by K4 Cl2H2 plus K3 K1 K2H2 by K3 K4 Cl2 DHCl by dt is equals to K1 K2 Cl2 H2 by K4 plus K1 K2 H2 Cl2 by K4. Now, since 2K1 K Cl2 plus 2IAB, then K1 Cl2 is equals to IAB. Use above result in equation 4. DHCl by dt is equals to K2 IAB H2 K4 plus K2 IAB H2 by K4. DHCl by dt is equals to 2K2 IAB H2 by K4. We conclude the hydrogen chlorine reaction is much higher than that of hydrogen bromine reaction, which may simplify be attributed to exothermic nature of the second step in S2Cl2 reaction, which makes it spontaneous in nature. Rice-Herzfeld mechanism of organic molecule decomposition for acetaldehyde. Frank O. Rice and Carl F. Herzfeld propose and study on chain reaction and develop special mechanism to account observed rate law in honor of research. This mechanism is known as Rice-Harbs reaction. The pyrolysis of acetaldehyde is a typical case of stationary type chain reaction. N is equals to 1, for which all reaction is CH3CHO, that is CH4 plus CO. Elementary step initiation CH3CHO K1 CH3 plus CHO propagation CH3 plus CH3 CHO K2 CH4 plus CH2 CHO CH2 CHO K3 CH3 plus CO. Termination CH3 plus CH3 K4 CH3 CH3. Net rate of formation of CH4 dCH4 by dt is equals to K2 CH3 into CH3 CHO. Overall rate expression. Apply steady state approximation on CH3 and CH2 CHO dCH3 by dt is equals to K1 CH3 CHO minus K2 CH3 into CH3 CHO plus K3 CH2 CHO is minus 2 K4 CH3 square. Similarly, dCH2CHO by dt is equals to 0 is equals to K2 CH3 CH3 CHO minus K3 CH2 CHO, taking negative both sides, minus K2 CH3 CH3 CHO plus K3 CH2 CHO is equals to 0. Use above result in equation second. K1 CH3 CHO plus O minus 2 K4 CH3 square is equals to 0. CH3 is equals to K1 by 2 K4 raised to power 1 by 2 CH3 CHO raised to power 1 by 2. Put values of CH3 in equation 1. dCH4 by dt is equals to K2 K2 into K1 by 2 K4 raised to power 1 by 2 CH3 CHO raised to power 1 by 2 CH3 CHO. dCH4 by dt is equals to K2 K1 by 2 K4 raised to power 1 by 2 CH3 CHO raised to power 3 by 2. Now constant and as K is equals to K2 into K1 by 2 K4 raised to power 1 by 2. Use in equation 3. dCH4 by dt is equals to KCH3 CHO raised to power 3 by 2. Kinetic chain length is equals to Rp and Ri is equals to rate of propagation and initiation. Ri is equals to Ki CS3CHO. After using Rp and Ri from above equation, in equation 4, kinetic chain length is equals to K CS3CHO raised to power minus 3 by 2 by K1 CS3CHO. Kinetic chain length is equals to K by K1 CS3CHO raised to power 1 by 2. Enzyme kinetics, the study of rate of enzyme catalyst reaction and how fact which such as enzyme concentration, substrate concentration, and the presence of inhibitor or activator influence these reaction mechanism. It helps to determine step of an enzyme catalyst reaction. E plus S in equilibrium, K minus 1 ES K2 P, where E is enzyme that bind to a substrate S from a complex ES. Overall step rate plus dP by dt is equals to R is equals to K2 ES. ES is intermediate steady state approximation. Applied rate of formation of ES is equals to rate of decomposition of ES. K1 ES is equals to K minus 1 ES plus K2 ES. K1 ES plus is equals to K minus 1 plus K2 ES. ES is equals to K1 ES by K minus 1 plus K2. Defining a new parameter named Michaelis-Menten constant Km is equals to K minus 1 plus K2 by K1. It form ES is equals to E into S by Km. The total enzyme concentration mathematically, E naught is equals to E plus ES. E is equals to E naught minus ES. Put the value of E in equation 1. ES is equals to E naught minus ES into S by Km. ES is equals to E naught S minus ES into S by Km. Rearranging for ES again, Km ES is equals to E naught into S E minus ES into S. Km ES plus ES into S is equals to E naught into S. ES is equals to E naught into S by Km plus S. Put value of ES in equation star. R is equals to K to E naught into S plus by Km plus S. Initial enzyme catalyst rate R naught is equals to K to ES E naught into S naught by Km plus S naught. It is well known as Michael-Menten equation. At very large initial substrate concentration, Km can neglected in comparison to S naught in denominator, which result R max is equals to K to E naught into S naught by S naught is equals to K to E naught. After using K to E naught is equals to R max in equation 11. In equation 2, R naught is equals to R max S naught by Km plus S naught, most popular form of Michaelis-Menten equation. Plot of initial reaction rate of enzyme catalyst reaction. Order of a enzyme catalyst reaction. It is understood by working at general form of Michaelis-Menten equation. At high, S naught is equals to when initial substrate concentration is very high, Km can be neglected. Equation 2 take form. R naught is equals to K to E naught into S naught by S naught is equals to K2 into E naught. Reaction will be zero order with respect to substrate concentration and first order with respect to total enzyme concentration. At low S naught, when S naught is low, S naught can be neglected and equation 2 form as R naught is equals to K2 by Km E naught into S naught, the reaction will be first order with respect to substrate concentration and first order with respect to total enzyme concentration. Calculation of catalytic efficiency Rmx is equals to K2 E naught into S naught by S naught is equals to K2 into E naught. K2 is equals to R maximum by E naught. Calculation of Michaelis Menten constant R maximum is equals to K2 E naught S naught by S naught. K is equals to E2 E naught. After using the K2 E naught is equals to R maximum in equation to R naught is equals to R maximum S naught by Km plus S naught. When initial reaction rate is half of maximum initial rate, that is R is equals to R naught by 2, R max by 2 is equals to R max S naught by Km plus S naught. Km plus S naught is equals to 2 S naught. Km is equals to S naught. Concentration at which initial rate in half of maximum initial rate will be equal to Km. The line where Burke plot. To understand line where Burke method for determination of maximum initial rate, R maximum and Michaelis constant rearrange general Michael maintain equation Prokhorov equation R naught is equals to R max into R S naught by Km plus S naught is 1 by R naught is equals to Km plus S naught by R maximum into S naught. 1 by R naught is equals to Km by R maximum into S naught plus S naught by R maximum S naught. 1 by R naught is equals to Km by R maximum into 1 by S naught plus 1 by R maximum, which is equal equation of straight line y is equals to mx plus c. It is also worthy to mention that if the intercept of further vector, it will lead to intercept on x axis that equal to minus 1 by Km. To Addy Hofstad plot, in order to understand the Addy-Hofstad method for determination of maximum initial reaction R maximum and Michaelis constant reaction Michaelis maintain equation 1 by R naught is equals to Km plus S naught by R max S naught. 1 by R naught is equals to Km by R max S naught plus S naught R max by into S naught. 1 by R naught is equals to Km by R maximum into 1 by S naught plus 1 by R maximum, multiply both sides by R naught. R naught by R naught is equals to M by R max R naught by S naught plus R naught by R maximum. Rearranging for R naught by S naught, we get R naught by R naught minus R naught by R max is equals to Km by R max R naught by S naught. R naught by S naught is equals to R naught by R naught R max by Km minus R naught by R max by Km. R naught by S naught is equals to R max by Km minus R naught by Km. R naught by S naught is equals to minus K1 by M R naught plus R max by Km. It is worthy to mention that if the intercept is further extrapolated with, it will lead to intercept on x-axis that is equal to R max.